Good morning all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the video lecture series on discrete time Fourier transform. See, signals is of continuous and discrete. Continuous is of periodic and non-periodic. In continuous time system, we can going to analyze with the help of Fourier series and Fourier transform. In digital, it can be divided into periodic and non-periodic. To going to analyze with the help of discrete Fourier series, discrete time Fourier transform and Z transform. See, these are the sum of the Fourier coefficient representation. Fourier transform of function of s of t. While we taking the time domain to frequency domain, transformation of the periodic summation of x of t, Fourier series coefficients. And then transformation of periodic sample x of t, discrete time signal sequence, and transform of both periodic sampling and periodic summation, discrete Fourier transform. It consists of your f of t, that is nothing but fast Fourier transform. This is the discrete Fourier transform, the process of conversion from time domain into frequency domain. See, time domain into frequency domain, the DTFT representation may also given in terms of x of n with respect to n. That can be converted into frequency domain x of e power j omega with respect to omega. Next one, discrete time Fourier transform. Discrete time signals are analyzed with the help of periodic signals. DTFS, that is nothing but periodic signals. DTFT, it consists of both periodic and non-periodic signal. Discrete time Fourier transform describes the spectrum of discrete time signal. Discrete DTFT of discrete time signal x of n is given as x of omega is equal to summation n is equal to minus infinite to plus infinite x of n into e power minus j omega n. This is while we taking the inverse discrete time Fourier transform, x of n is equal to 1 by 2 pi integral over minus pi to plus pi x of omega into e power j omega n into d omega. Existence of DTFT of x of n will converge if x of n is absolutely summable. Summation n is equal to minus infinite to plus infinite. Modulus of h of n should be less than infinite. Next one, this is the DTFT constant function. This is x of n can be already given in terms of discrete time signal. While we taking the discrete time Fourier transform, we can get the frequency response of the system with respect to pi, minus pi, 2 pi, minus 2 pi, 4 pi to minus 4 pi with respect to omega. Next one, this is the representation of DTFT and DFT. First one, x of n with respect to n minus 1. Next one, DTFT of omega. While we taking the above function discrete time Fourier transform of x of n, we can get the DTFT of omega. While we taking the DFT of x of n, we can get the frequency response as like this. Next one, DTFT sinusoidal function. This is the cos omega naught t. While taking the discrete time Fourier transform of cos omega naught t, this is the representation of frequency domain signal. This same domain minus 2 pi to plus 2 pi with respect to omega. Del of omega plus omega naught, del of omega minus omega naught. Del function can be represented as 1 for n is equal to 0, 0 for n should be not equal to 0. This is the DTFT impulse function. Del of n is equal to 1 for n is equal to 0, 0 for n should be not equal to 0. The impulse function, while we taking the discrete time Fourier transform of impulse function, we can get the frequency response like this, minus pi to plus pi, extent of the frequency band of discrete time frequency domain. Next one, find the discrete time Fourier transform of x of n is equal to a power n into e of n. X of omega is equal to summation n is equal to minus infinite to plus infinite x of n into e power minus j omega n. A power n into e of n, we can take n terms as common. A into e power minus j omega the whole power n. Now we can substitute from 0 to infinite. 1 plus a e power minus j omega plus a e power minus j omega the whole square. 1 plus a square becomes 1 divided by 1 minus a. Therefore, x of omega is equal to 1 divided by 1 minus a e power minus j omega. X of n of u of n, same formula of DTFT. X of omega is equal to summation n is equal to minus infinite to plus infinite x of n into e power minus j omega n. U of n represents 0 to infinite into e power minus j omega n. Instead of n, you can substitute 0 to infinite, 1 plus e power minus j omega plus e power minus j omega the whole square. Therefore, 1 plus a square becomes 1 divided by 1 minus a. Therefore, x of omega is equal to 1 divided by 1 minus e power minus j omega. This is the discrete time Fourier transform of 1 for minus omega t is to plus omega c. While we taking the inverse Fourier transform, x of n is equal to 1 by 2 pi integral over minus pi to pi x of omega into e power j omega n into d omega. 1 by 2 pi integral over minus omega c to plus omega c, x of omega as value as 1 into e power j omega n into d omega. When 1 by 2 pi e power j omega n divided by j n integral over minus omega c to plus omega n, now we can substitute as x of n is equal to 1 by n pi into sin omega c of n. When n is equal to 0 means n becomes 0, therefore 1 by 2 pi omega into minus omega c to plus omega c, 1 by 2 pi into 2 omega c, 2 gets cancelled, therefore x of n is equal to omega c by pi. When n should be not equal to 0, x of n is equal to 1 by n pi into sin omega c of n. When n is equal to 0, x of n is equal to omega c by pi. Next one, DTFT properties. It consists of linearity property, time shifting property, frequency shifting, differentiation, convolution and Parseval's relation. The linearity property, when n terms becomes DTFT, ax into x of e power j omega plus b into y of e power j omega. Time shifting, x of n minus n naught means e power minus j omega naught into x e power j omega. Frequency shifting, e power j omega n into x of n is equal to x of e power j into omega minus omega naught. For similarly for convolution, multiplication and Parseval's relation. Next one, applications of Fourier transform. Fourier transform can be used to analyze the problems involving mixtures of continuous and discrete time signals. Discrete time Fourier transform are most commonly used for analysis applications, is the primary representation of computational applications, converges periodic signals, to analyze problems involving mixtures of both periodic and aperiodic signals. Now we can see the assessment. Define discrete time Fourier transform. DTFT can be defined as x of omega is equal to summation n is equal to minus infinite to plus infinite x of n into e power minus j omega n. Discrete time signals are analyzed with the help of periodic signals. List the properties of DTFT. It is of linearity property, frequency shifting, time shifting, convolution property, multiplication property and Parseval's relation. Discrete time Fourier transform of unit step signal is given by x of omega is equal to 1 divided by 1 minus e power j omega. Mention the applications of DTFT. Fourier transform can be used for discrete time Fourier transform, most commonly used for analysis applications. It is used for analysis of both periodic signals and aperiodic signals. The existence of discrete time Fourier transform is given by summation n is equal to minus infinite to plus infinite. X of n should be less than infinite. The unit impulse function of DTFT is nothing but x of omega is equal to 1. Thank you.